We do dull, dirty, or dangerous jobs, as you can see. These are a little bit of a movie showing some of the ones that we have in our government industrial side. As you can see, some of our customers don't treat our stuff very nicely at all.
What is this supposed to do?
You'll see a little bit more of it in a minute or two. That's one of our sea gliders. That's our big warrior. That's the Sugby on the guy's back. Another one going through the door. Here's a little guy tossed up through the window. He's going in, clearing out, checking out what's going on in the rooms and stuff.
Oh my god.
Yes, they can go underwater. They are pretty waterproof. We have to make them pretty durable.
Xbox.
And yes, an Xbox controller. Yes. And yes, as I said, our warrior is a big guy, and he can actually haul a truck. That's our first look. It's actually one of our newest products. So, now that I've spieled a little bit about iRobot and what a cool place it is and how much I enjoy working with it, let's talk a little bit about robots and how they work. We have autonomous robots. Anybody want to tell me what an autonomous one means? Yes, young man.
Like, there's no person like controlling it.
That's right, there's no person controlling it. It is automatic, it has the ability to start, operate, and move independently without human contact. Like our friend, the Roomba over here. Then we have control. The robot is told what to do by human interaction. Our friend, the Packbot over here. So how is it that they work? We have mechanical design, which is the robot body, which of course is the most important part. Maybe because I'm a mechanical engineer and I'm responsible for that, but that has nothing to do with it. And then you have sensors and behavior, which is basically electronics and software. And that gives you robot action. So you've got the three main important areas of robotics: mechanical, electrical, and software. Mechanical design, which is what I do, has anything to do with making it move, anything to do with the structure of the robot, what it's made out of, what it's going to be, how it's going to be fabricated, what it needs to do. For instance, there's a big difference between designing our friend the Roomba over here for vacuuming your floors in a nice, sanitary, clean environment like your house, which is pretty reasonable. It's not usually very much of a temperature fluctuation. It doesn't go from minus 40 degrees to Celsius to 60 degrees Celsius, and it's usually pretty clean. To our friend the Packbot here, who, as you can see from some of our guys, they toss them around, they drop them off of trucks, they're used in the water, they go over rocks, they're used over in deserts where it's 120 degrees. Big difference. So, you know, depending upon what it is you're designing, you have to, depends upon what you're going to use for materials and what have you. Packbot, our friend here, has a camera. It's got an arm with some grippers on it. It's got batteries to make it move. It's got tracks. And flippers. And the flippers, what do you think the flippers help it with? You guys would be answering all that questions over here. Let's get the guy in the striped shirt back there. That's you.
To like float in
To what?
the water.
To float in the water? That might help a little bit. How about you? You got it.
Oh, like when it goes to the deep water, it can actually like move.
Well, it could be. How about you? There in the red glasses.
Elevation?
I'm sorry?
Elevation?
Elevation. A bit, yeah. No, you already answered.
Move rocks aside or something?
Rocks aside. It certainly does help when it comes to rocks and stuff, because us to climb over and what have you. Yes?
Stairs.
Ooh, okay, there you go. Stairs. Yes, believe it or not, sorry. Our friend here can climb stairs. These are the kinds of things that basically an engineer in general does, is figures out how to solve problems, right? You know, somebody says, well, geez, we need something that's going to go up the stairs. In fact, that's how the Packbot came to be. The people at DARPA, which is a government agency, sent out a big invitation, said, okay, all you guys, all you smart guys out there, give me something that can go up the stairs. We came up with this really cool thing and came up the stairs. They were actually just asking for a proof of concept, but we actually gave them a working prototype. And because of that, they awarded us some money, and the company just kept going on and on from there. So now the electrical engineers, robots have got sensors like human beings. We have senses, the robot has sensors. Like, we can see. The robot has cameras and infrared sensors, two types of infrared. There's long wavelength, which is heat, and there's short wavelength. You guys actually deal with shortwave infrared all the time. I'll bet you every single day you touch something in your house that has infrared in it. Every single day. I will bet you guys $1,000. Yes? Television remote. Now, there's a kid who actually studied before he came here. And it's not even a school week. This is very impressive.
Isn't infrared like kind of invisible light almost?
It is actually light. It's one of the wavelengths of light that you can't see. Just because you can't see it doesn't mean something else can. Yes, your eyes only respond to certain wavelengths of light from near ultraviolet up to short infrared, basically from 400 to 750 nanometers. All right, I just lost half of them. All right, most of them, right. Anyway, sorry, my total geek. It just comes with the territory. Anyhow, the infrared that comes on your television remote, which you can't see, doesn't mean that our friend Roomba here can't. You have sensors, it sends out a beam, that's the transmitter, and then it receives back a signal. So in the case of our friend here, she sees my hand and she slows down. She sees my hand because of an infrared sensors around the front that sends out, and when it's approaching a wall, it actually bounces back and tells the thing, hey, I'm approaching something, I better slow down. So now we've got hearing, right, with our ears. Our friends, the pack by here is microphones. The Roomba actually can hear too. The Roomba has, ooh, wow, that's a pretty long word. It says piezoelectric sensor. When you're vacuuming, how do you know when something's dirty? How do you know when it's particularly dirty? Okay, you've already gone over it. You're already running over the dirty spot.
Yeah.
Right, you can hear it. It's making lots of noise. You first go over it, it's going, as it's picking up all the Legos that you guys left behind, and the little Barbie stuff, and her little shoe, and the Polly Pocket shoe, and her little purse, and what have you. And then finally, and it slows down, and then you know, okay, it's clean, I can stop. Well, that's how our Roomba knows, the same thing. The Roomba does it by sound, it actually listens. When it goes over a dirty spot, the little light comes on, the little blue light comes on, it says, dirt detector, and it starts to spin around, and it stays in place until it makes less and less sound to the point where it says, okay, now this area is clean, I can keep going. No more Legos. Touch. We've got hands and feeling the touch. And we have a bump sensor, which is this, right? When it comes along and it hits something, it bumps. And it says, okay, I hit something, it's time for me to turn. First it says, I see I'm coming near something, and then it actually hits it and bumps it and says, okay, it's time for me to turn. And now, smell and taste. Well, all right, that thing doesn't smell or taste. This doesn't exactly smell or taste, but as I mentioned before, over in the Fukushima plant, it does have chemical sensors, and it also has radiation sensors. Those are the types of things that we can equip these units with for particular things. We actually have a unit that's called Fido, yes, like a dog, and it is equipped with a sensor for sniffing out things like explosives. A friend of Roomba here, you just throw me way off, has got bump sensors, as we talked about. It has IR sensors. Now, you were talking about our virtual wall friend for cliffs. However, I don't have a virtual wall set up here, but it's not falling off the edge. Instead, what you see is these guys right here. And guess what they are again?
Infrared.
Thank you. Yes, they are. They're infrared. In essence, what they're doing is they're sending a little light beam out, it hits the ground, and bounces up on the other side. Now, once it goes off an edge, guess what? That beam goes out, and it doesn't come back.
So it turns around.
So it says, Cliff, turn around, now. Answer Cliff sensors. Now, it also has wheel drop sensors. You know, I do have to be I have to go to work tomorrow. Yes, young man.
They're probably spring-loaded so that they can come back up.
You want a job? Wow. He's right. They are spring-loaded. The reason being, if our friend here is cleaning and I pick it up, I certainly don't want it to keep on going because this can be really annoying to have this thing going in my hand. And also, if it gets stuck, the wheel just hangs off the edge of a cliff, as it were. You don't want it to stay, you don't want it to keep going either. It has a caster sensor. That's what that little part you were pointing to was. And no, I'm not going to ask anybody over here. This side of the room does not exist right now. Anybody over here want to tell me why part of my wheel is white and part of my wheel is black? Anybody, and not you. Come on. Left side of the room, you're getting totally shown up over here. Come on, you gotta pull together here.
In case you get stuck somewhere, it could sense that the color is not coming around again.
That certainly does help. It does tell it that it's not moving. That helps. Why else would we want to know if it's moving? No, remember, you guys don't exist right. Yes.
To know to back up, like if it got stuck in if there's a part of a hole in the ground.
Could use that. All right, fine. You exist. Yes.
It counts the number of times it sees the colors change, so it knows how far away.
All right. Did you spend all day on our website, fishing around or something? Yeah. Okay. At least you're honest about it. And yeah, you got it. That's exactly what it does. It uses the number of times that the thing goes. I can't even say anything about it. He already said it. It counts the number of times the wheel goes around. And it keeps track of where it's been. That way it actually maps out your room. Unfortunately, it doesn't save that map because if you go from one room to another, it doesn't know what room you're in. But it does know how far it's going, and it maps out the room and figures out how much of the room it's covered. That way it knows when it's done. Otherwise, it's just going to keep on running until it runs out of juice. And then, of course, our friend the piezoelectric sensor, which we already talked about. Hey, there we go. Software. Now, this is where the magic is. I won't even pretend to say I understand what the guys in software do. All I know is that they write all these cool algorithms and programs and stuff to figure out when it's gone far enough and how to do what and so forth. However, what they're needed for is to turn our friend the Roomba here into doing simple things that you don't even think too much about, right? Say our little dirty spot on the floor that our mom back here pointed out. Yes, you see it. Look, there's dirt. Okay. You just have your brain sending signals that says, use your muscles and go and do something. Well, the Roomba has to have sensors and circuits to tell the electronics to go and do something. You go, you pick up your vacuum, and you go and do the work and vacuum the dirt. Or you have our Roomba friend here, notice that it's dirty and go and do the job for you instead.